Hello students, this is another lecture on vectors. In this lecture, we are going to take exercise 5.2 remaining problems. So in this, we have question number 5 to be done. Now in this question, you can see we have question number 5 is prove that the line segment joining midpoint of adjacent sides of a quadrilateral form a parallelogram. What we have to prove? We have to prove that line segment joining midpoint of adjacent sides of a quadrilateral form a parallelogram. Now here, they haven't said anything about the quadrilateral. So what does that mean? It means that it could be any kind of quadrilateral. So I have drawn a quadrilateral ABCD. You can see this quadrilateral ABCD, which is drawn with the white color. So ABCD. And then we have midpoints of the sides. The midpoint of side AB is D. Okay, it is midpoint. So AE is equal to EB, right? And same way, I have midpoint of BC as F, and midpoint of CD is G, midpoint of AD is H. So the quadrilateral which I get by joining the midpoint of these adjacent sides is EFGH. Which quadrilateral do I get? I get EFGH. Okay, so this quadrilateral I'm getting. What I have to prove? I have to prove that quadrilateral EFGH is a parallelogram. I have to prove quadrilateral EFGH is a parallelogram. So you have to understand the data first. What is the data? The data is there is a quadrilateral, any kind of quadrilateral. Then you have the midpoints of the sides of this quadrilateral. Now, when you join these midpoints of the adjacent sides, you get another quadrilateral, and this quadrilateral has to be a parallelogram. This is what we have to prove. This is to be proved. So we have to prove this, that EFGH is a parallelogram. Now see, how do I prove it? I will start with writing, consider a quadrilateral ABCD where points E, F, G and H are midpoints of segment AB, BC, CD and AD respectively. Then I will write, let A bar, B bar, C bar, D bar, E bar, F bar, G bar and H bar be the position vectors of points A, B, C, D, E, F, G and H respectively with respect to O, that is origin. So now check this out. We have to use a vector method to prove that quadrilateral EFGH is a parallelogram. Now you need to understand, if you want to prove that EFGH is a parallelogram, it would be sufficient if you prove that vector EF, if you could prove that vector EF, that is, it starts from E and up to F. If you can prove that vector EF is equal to vector HG, or for that matter, if you could prove vector EH is equal to vector FG, either of the two you prove and your proof is done. See, we know that if I could prove EF, vector EF is equal to HG, if I could prove vector EF is equal to vector HG, or vector HE is equal to vector GF, if either of these two I prove, I have proved that the quadrilateral is a parallelogram. Now, how does that happen? See, when two vectors are equal, try understanding. If the two vectors are equal, it means they are in the same direction and they have equal magnitude. So if EF and HG, if vector EF is equal to vector HG, it means the magnitude will be equal. The magnitude of these two vectors will be equal and their direction will be same. Now, when will the direction be same? Only when they are parallel. Only when they are parallel. So you proving this, you have proved that EF is parallel to HG. If you could prove this, it means you have proved that EF is parallel to HG. Moreover, you have also proved that EF and HG are equal in magnitude. Now you understand, if that is happening, so EFGH will become a parallelogram. Okay, so we will start with the proof now. I will apply the midpoint formula for point E. Now E is midpoint of AB. So I'll be writing here by midpoint formula. E bar equals to A bar plus B bar upon 2. See, E is midpoint of AB, so E bar is A bar plus B bar by 2. Same way here I have point F, which is midpoint of segment BC. So I will write F bar equals to B bar plus C bar by 2. G bar equals to G bar equals to C bar plus D bar by 2. And H bar equals to H bar is equal to A bar plus D bar by 2. Now, after getting these position vectors, I will find out I have to incorporate, somehow I have to incorporate EF. I want to get EF vector. You understand? Vector EF. So I will find out, therefore, EF bar equals to, as you know, displacement vector EF bar will be F bar minus E bar. So that is F bar minus E bar. I will get here B bar plus C bar by 2 minus A bar plus B bar by 2. So I have common denominator. I have 2 here. This is B bar plus C bar minus A bar minus B bar. B bar cancels. So I get here C bar minus A bar upon 2. This is EF bar, which is number 5. Then after getting EF bar, as I had told you, I will go for HG bar. Now I will go for, see, I found EF bar. Now I go for HG bar. I write here, similarly, HG bar is equal to G bar minus H bar. G bar and H bar I have already found here. So this is so I get therefore HG bar equals to Common denominator is 2. I get here C bar plus D bar minus A bar minus D bar. When you open the bracket, A bar and D bar both become negative. So here you get Hg bar equals to D bar cancels, C bar minus A bar upon 2. Now see, when C bar minus A bar by 2 you get, this is number 6. So from 5 and 6, we have, see, the RHS of 5 and 6 are equal. So what you have, therefore, EF bar is equal to HG bar. Now see, this is enough. This is sufficient for proving that the quadrilateral EFGH is a parallelogram. This is sufficient for proving. Your problem is over. You have already proved. What you will write? Therefore, the quadrilateral EFGH is a parallelogram. Hence, proved. Now, in case if you still thinking that how is the proof done, I will show you by drawing the diagram. See here, you have EF bar is equal to HG bar. Now, what I suggest to you is you draw EF bar. This is say EF bar. Now you have to draw Hg bar, which should be equal to EF bar. Now what does that mean? It means that Hg bar has to be in the same direction as EF bar and it should have the equal magnitude. So here I now draw Hg bar. See here, this is Hg bar. So this thing I have drawn here, EF bar is equal to Hg bar. Now if I join E with H, and G with F, see what I am getting. Am I not getting a parallelogram? Yes, see, this is a parallelogram. So if you have proved this, you have actually completed the solution. I hope you have followed this. Let's go for the 7th question from the same exercise. We have to prove that a quadrilateral is a parallelogram if and only if its diagonals bisect each other. Now this particular question is very interesting. See, the reason is you have got here the connective. It is a connective. If you have done mathematical logic, you would know that if and only if is a connective. Okay, so the question involves if and only if. Now, because of this if and only if, this thing becomes very interesting. See, we have to prove that a quadrilateral is a parallelogram. A quadrilateral is a parallelogram. Let me color this with pink color. A quadrilateral is a parallelogram if and only if its diagonals bisect each other. So let me color this with green color. If and only if the diagonals bisect each other. So here we have got, in this one statement, we have got two statements. See, what is that? The first one is a quad if. Okay, let me now take you to mathematical logic. If you remember, students, when we have P double implication Q, if and only if is double implication. So when I have P double implication Q, P if and only if Q, what does that mean? It means if P then Q and if Q then P. So remember, if you have P if and only if Q, then P if and only if Q is equivalent to if P then Q, P implies Q, and if Q then P, Q implies P. Now what does that mean? Here, if I take this as P, statement P, and this as Q, this given statement in the question will now give rise to something like this. And what is it? It will be if a quadrilateral, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, this will be the first part, and the second part will be if the converse of the first part, if diagonals of a quadrilateral bisect each other, then quadrilateral is a parallelogram. I hope you all are following what is happening here. See, what I have done is this particular statement, which comprises of if and only if, which has got if and only if, I have broken it into a statement where I have got two if then. I have got two if then. If then and if then. So see, the first in this statement, what is given? We are given a quadrilateral is a parallelogram if and only if its diagonals bisect each other. So the first statement would be the data is we have a quadrilateral which is a parallelogram. See, the first data is we have a quadrilateral which is a parallelogram, and we have to prove that its diagonals bisect each other. The first part of the proof will be, if you want to prove this statement, what you will have to prove? You will have to go in two steps. Remember, you will have to go in two steps. The first statement will be, you have the quadrilateral as a parallelogram, and you will prove that its diagonals bisect each other. Then the next one will be, you will have this as a data, that is the quadrilateral have its diagonals bisecting each other. The diagonals are bisecting each other, and you will prove that quadrilateral is a parallelogram. So what we will do is, first we will go for this part in which the data is there is a quadrilateral, and we will prove the data is there is a quadrilateral which is a parallelogram, and we will prove that the diagonals are bisecting each other. I repeat, we will first go for the part where the quadrilateral is a parallelogram, and this is the data given thing. We will prove that the diagonals will bisect each other. So let me start with it. Here my solution starts. I will write, consider a parallelogram A, B, C, D, and I draw a parallelogram here. So here I have a parallelogram A, B, C, D, and what is to be proved? I have to prove that the diagonals will bisect each other. So A, B, C, D being a parallelogram, I have to prove that diagonals are going to bisect each other. So let me draw the diagonal AC and BD. I have to prove that AC and BD are going to bisect each other. So let me start by writing let A bar, B bar, C bar and D bar be the position vectors of points A, B, C and D respectively with respect to origin O. Okay, now what I will do is, since I'm given that ABCD is a parallelogram, since that is data, I can always write AB bar is equal to DC bar. I write here, we can write AB bar is equal to DC bar. Now when I'm writing, why I'm writing AB bar equals to DC bar? Because I am given ABCD is a parallelogram. Remember, you cannot write AB bar equal to CD bar because CD bar is opposite direction. You will have to write DC bar. Now here I will get, therefore B bar minus A bar is equal to C bar minus D bar. Let me do the shifting here. So let me take D bar with B bar. So D bar I take on the left and A bar on the right hand side. So what do I get? Therefore, B bar plus D bar is equal to C bar plus A bar. So in the next step, I will divide both sides by 2. So I will get, therefore, B bar plus D bar upon 2 equals to A bar plus C bar upon 2. Now here what I am getting, I want you all to look at both the sides one by one. So let me have first the left hand side. Now what does left hand side give us? Left hand side is the, let me write this as equation number 1. I will write this as equation number 1. So here I write the LHS of equation 1 is position vector of midpoint of BD. You have to agree this. Why? Agree to this. Why? Because B bar plus D bar by 2. B bar plus D bar by 2 is nothing but the position vector of midpoint of segment BD. Now just imagine you have BD here. Let me draw BD. Just imagine you have BD here and you have the midpoint of BD here. Okay. So if B bar, B bar would be the position vector of B and D bar would be the position vector of D. What will be the position vector of M? It will be definitely, which is midpoint, M is midpoint, so it will be B bar plus D bar upon 2. So M bar will be B bar plus D bar upon 2, and that is what I am getting here on the left hand side. So what I will write? I will write the left hand side. I have written the left hand side of equation 1 is position vector of midpoint of BD. Similarly, look at the right hand side. I will write the RHS of equation 1. RHS of equation 1 is position vector of midpoint of AC. But when you have these two equal to each other, see, there is an equal to sign in between. What does that mean? It means that position vector of a point here is same as position vector of a point here. It means those are not two different points, they are same point. What does that mean? It means that midpoint of BD, this is midpoint of BD and this is midpoint of AC. And since they are equal, it means midpoint of BD is same as midpoint of AC. So I will write therefore midpoint of BD and AC is a common midpoint, Now you tell me, if two segments, let me draw here two segments, okay, if two segments are having same midpoint, BDAC, see, midpoint of BD, midpoint of BD is same as midpoint of AC. When one single point is midpoint of both the segments, what does that mean? It means that these two segments are bisecting each other. Because of this point, AC is divided into two equal halves and BD is also divided into two equal halves. So the next statement I will write is therefore AC and BD bisect. Therefore AC and BD, I should have written here diagonal AC and BD. Okay, so I'll do that correction. Therefore the diagonals AC and BD bisect each other. So we have proved the first part. What was the first part? The first part was we started with a parallelogram. And we proved the diagonals are bisecting each other. What will be the next one? You have to prove both. Remember, because you have got if and only if. Okay. So what will be the next one? The next one will be here. You can check. In this, what we are going to start with, we will start with diagonals of the quadrilateral are bisecting each other. Now what we are going to do is exactly the converse. It is the converse of the earlier thing that we did. Here we will start with what we proved in the earlier one. Here we will start with the data as diagonals are bisecting. We will start with the data as diagonals are bisecting. And what we have to prove? We have to prove that in such case, the quadrilateral will be a parallelogram. Will be a parallelogram. So here I start with the next part. I write here second part, and here I will write the first part. I will start with consider a quadrilateral ABCD whose diagonals AC and BD bisect each other. See, I have started with a quadrilateral where the diagonals are bisecting each other. I draw a quadrilateral. And will draw the diagonals which are bisecting each other. So what is the data this time? The data is AC and BD bisect each other at point M, say. So I will write let M be the midpoint, M be the midpoint of diagonals AC and BD. Okay. Therefore, by midpoint formula, see, in this case, I repeat once again, in this case, we are not having a parallelogram. We are not working on a parallelogram. We are working on two diagonals of a quadrilateral. That quadrilateral, we do not know what it is. We are working on its diagonals where the diagonals are bisecting each other. So what I will write, see here, M bar, okay, for diagonal, midpoint formula for diagonal AC, what I will have, M bar equals to, see, M bar will be equal to A bar plus C bar. You know what are those? They are the position vectors. Here A bar, position vector of point B as B bar, C as C bar, D as D bar, and M as M bar, position vector. So I will write M bar equals to A bar plus C bar by 2. Okay. And then I will apply the midpoint formula for diagonal BD, for diagonal BD. See, M is midpoint of AC and it is also midpoint of BD. So what will be M bar? B bar plus D bar upon 2. M bar is B bar plus D bar upon 2. I write this as number 2 and here number 3. What I notice, number 2 is M bar, number 2 equation is M bar, and equation number 3 is also M bar. So therefore, from 2 and 3, I can write A bar plus C bar by 2 equals to B bar plus D bar by 2. So this 2 cancels. So A bar plus C bar is B bar plus D bar. What I will do is I will shift here. A bar I shift on the left. So and D bar on the right. Okay, I'm sorry, A bar on the right and D bar on the left. So here I will have C bar minus D bar equals to B bar minus A bar. B bar minus A bar. So now what is C bar minus D bar? It is DC bar, and this is B bar minus A bar is AB bar. Okay, see, you have got DC bar equals to AB bar. What does that mean? DC bar equals to AB bar. If I have DC bar equals to AB bar, draw DC bar, okay, and then this is your DC bar, and then what you need to do is draw AB bar which is equal to DC bar. Okay, so take AB bar anywhere which is equal to DC bar. Now if AB bar is equal, it has to have same length, see, same length, and it has to be in the same direction, so that makes it parallel. Okay, see, it has to have the same direction. Now same direction will give rise to parallel vectors. So DC bar is equal to AB bar. Now join this. So see, you get AD and BC. So what is it? Are you not getting a parallelogram? So what did you start with? You started with the diagonals. You started with the diagonals. And what did you end up with? You end up getting a parallelogram. So I hope you have understood. So here I will write, therefore, the quadrilateral ABCD is a parallelogram, hence proved. So in this question, in this proof, what was most important? The most important thing was you had to prove, in order to prove this thing, you had to go for the answer in 2 steps. And why 2 steps? Because of if and only if. If and only if is equivalent to 2 if then. Okay, if and only if is equivalent to 2 if then. See, this is if then, this is also if then, and in between you have and. So what we did, first we go for given a quadrilateral parallelogram. We first went for given a quadrilateral is a parallelogram, and we proved diagonals bisect each other. Second, we went for the diagonals of the quadrilateral are bisecting and proved that it is nothing but a parallelogram. This completes the proof. I hope you all have followed it. You can watch this again and try to write this. Minimum 2 times you need to practice this. Minimum 2 times. Let's go for the next question. Question number 8. Prove that the median of a trapezium. Median of a trapezium. You all understand what is a trapezium? Median of a trapezium is parallel to the parallel sides of the trapezium. Median of a trapezium is parallel to the parallel sides of a trapezium. You all understand a trapezium has 2 parallel sides. Okay, so we need to prove that median of a trapezium will be parallel to the parallel sides of the trapezium. Further, and its length, its length means the length of median, and its length is half the sum of parallel sides. Okay, so for that I will have to first tell you what is meaning of median of a trapezium. You all know what is a trapezium. You need to now understand what is median of a trapezium. So for that I will show you a trapezium. So look at this. I have a trapezium here, ABCD. This is trapezium ABCD, and the 2 parallel sides are AB and DC. See, AB and DC are parallel sides. What is a median? In order to get the median of the trapezium, you will have to get the midpoints of the non-parallel sides. So let M be the midpoint of AD and N be the midpoint of BC. Now you join these 2 points, M and N. Now, when I join these midpoints, M and N, I get the median of trapezium. What I got? I got the median of trapezium. So now I hope you understand what is median of a trapezium. Let us read the question once again. Prove that median of a trapezium, that is MN, is parallel to parallel sides of the trapezium. I have to prove that MN will be parallel to AB and DC. I will have to prove that MN is parallel to AB and DC. Number 1 of the proof. And what is the second thing that I have to prove? I have to prove that its length, that is length of MN, is half the sum of the parallel sides. That is, I have to prove that MN will be equal to 1 upon 2. The length of MN, length of trapezium, is half the sum of the lengths of parallel sides, that is half AB plus DC. So there are 2 things to be proved in this question. First, prove that MN is parallel to AB and DC. Second, prove that length of MN is half 1 by 2 times sum of the length of parallel sides. I hope you followed the question. Now we will go for the solution. Not to be mentioned, you will have to draw the diagram. So you draw the diagram in your answer and then you begin as follows. You will write here, consider a trapezium, consider a trapezium A, B, C, D as shown in the figure, okay. MN is median of the trapezium. Then I write, let A bar, B bar, C bar and D bar. See, you have to go for the position vectors. Okay. You are proving all this by vector method. Now, if you are using the vector method to prove the question, you will have to consider the position vectors of these points. So, what are the vertices of trapezium? It is points A, B, C, D. Now, what you do, you join these points from the origin. Somewhere you have to consider origin and then you join. So what you will get from origin. Suppose this is O. So from O to A, you will get OA bar, which is A bar. Then O to B is OB bar, which is B bar, and so on. And as I have told you earlier, you don't have to show these position vectors. You just have to consider them. Okay, it is taken for granted that somewhere origin is there and these vectors are there in space. So let A bar, B bar, C bar and D bar, okay, also M bar and N bar be the position vectors of points, A, B, C, D, M and N respectively with respect to origin O, right? Now, what I have to prove? I have to prove that MN is parallel to AB and DC. MN is parallel to AB and DC. See, if I have to prove MN parallel to AB DC, somehow I have to incorporate MN. I will have to somehow get MN in picture. So see, how do I begin? Well, let me write here in this beside A bar. This is beside point B. I write B bar. This is C bar. Here I have D bar, this is M bar and N bar. Okay, I will apply midpoint formula for the side AD. I will write here by midpoint formula, See what I have, M bar, which is midpoint of point M is midpoint of AD. So I will have here M bar equals to A bar plus D bar upon 2. This is 1. And N bar, which is N point, N is midpoint of BC. So N bar is B bar plus C bar upon 2. This is equation number 2. What I will see, I've got M bar and N bar. And what am I working for? I'm working for MN. So I will now incorporate, I will get MN bar in picture. So I will write, therefore Mn bar equals to, what is it? N bar minus M bar. So N bar, what was N bar? Substitute, minus. What was M bar? Substitute. So N bar is B bar plus C bar by 2. B bar plus C bar by 2. And what is M bar? M bar is A bar plus D bar by 2. A bar plus D bar upon 2. Now you have common denominator 2, so you'll get 2 here, and see here what you get. You get B bar plus C bar minus A bar minus D bar. Okay. What I want you to now do is write A bar with B bar. So here you have B bar minus A bar plus, right, D bar with C bar minus D bar upon 2. Now you know B bar minus A bar gives you AB bar plus C bar minus D bar gives you DC bar, the whole upon 2. And here you have MN bar. Now this particular equation is of special importance. How? You will now know it. See, therefore this equation, I will write it as, therefore, Mn bar equals to 1 upon 2 times AB bar plus DC bar, AB bar plus DC bar. I write this equation as equation number 3. See, this equation number 3 has our solution completed. If you have understood equation number 3, you will understand that your solution is complete. Now, how is that happening? Just understand. Look at the RHS of equation number 3. In RHS, you have AB bar plus DC bar. See, you have AB bar plus DC bar. Now, you all know, students, that sum of two vectors is a vector. Sum of two vectors is again a vector. If I add a vector with a vector, what I'm going to get is another vector, right? Look at AB bar and DC bar. AB bar and DC bar here. See, AB bar and DC bar. These two vectors are parallel to each other. AB bar and DC bar are parallel to each other. So if they have same direction, they are parallel to each other, their sum will definitely be once again in the same direction. What I'm trying to tell you is, if I'm adding these two vectors, AB bar and DC bar, the sum that is AB bar plus DC bar, this sum of the two vectors will definitely be in the same direction. The resultant AB bar plus DC bar will have the same direction. Are you getting? That is, this vector, which is AB bar plus DC bar, is also parallel to AB bar and DC bar. Okay. Further, so AB bar plus DC bar is nothing but a vector in the direction of AB bar and DC bar, to which Mn bar is equal. See, Mn bar is 1 by 2 times this. You know the idea of scalar multiple. If one vector is a scalar multiple of another vector, I repeat again, if one vector is a scalar multiple of another vector, it means the two vectors are parallel. So from this, what I can say? I can say here, I will say, since Mn bar is scalar multiple of AB bar plus DC bar, therefore Mn bar is parallel to AB bar plus DC bar. And you already know that AB bar plus DC bar is parallel to AB bar and DC bar. Hence, Mn bar, which is nothing but the median, Mn bar is parallel to parallel sides. You have proved the first part. You have proved that median of the trapezium is parallel to the parallel sides. Next, I have to go for the length of the median. I have to go for the length of the median, for which what I will do is I will take the magnitude on both sides of equation 3. So I write here, from equation 3, we can write, what we can write from equation 3? Mod Mn bar. See, I'm taking magnitude on both sides of this equation 3. So I have mod Mn bar equals to mod of 1 by 2 times AB bar plus DC bar. That is equal to 1 upon 2 is a constant. It will come out mod of AB bar plus DC bar. This is Mn bar magnitude. Now, what does this prove? This proves that the length of the median, see, mod Mn bar is nothing but It is nothing but the length of Mn. So magnitude of Mn bar is the length of the median. So I have proved that length of the median is 1 upon 2 times sum of lengths of the parallel sides. Okay. So next step you will write, therefore mod Mn bar is equal to 1 upon 2 times mod AB bar plus mod DC bar. Okay, that is the length of median of trapezium is equal to half the sum of parallel sides. This completes the whole solution. I hope you have followed it. I explained in much detail. You can watch the whole solution once again and try solving this on your own. Now let's move to question number 10 from the same exercise. This question is in triangle OAB. You have a triangle OAB. E is the midpoint of OB and D is the point on AB such that AD is to DB is 1. Okay, so you have a triangle OAB. Okay, I draw a triangle OAB. A triangle OAB, right? What do they say? They say E is the midpoint of OB. So here you have E, which is midpoint of OB. What do they say further? They say, and D is the point on AB. D is the point on AB such that AD upon DB is 1. So see, D is a point on AB. Here you have AB and D is a point on AB such that AD, see the ratio is given as AD upon DB is 2:1, that is 2 upon 1. Now you notice that in numerator you have D, the denominator also you have D. It means point D is dividing AB. Point D is dividing AB in the ratio 2:1. So A to D is 2. So here you have D, you have A to D as 2 and D to B is 1. So that is what it means. AD upon 2B, I'm sorry, AD upon DB is 2:1. So that means D divides segment AB in the ratio 2:1. So AD is 2 sections and DB is 1 section. Okay. AD is 2 parts and DB is 1 part. Further, they say if OD and OE intersect at P, OD join O with point O with point D and point A with point E. They say OD and AE, they intersect at point P. This is the point where they intersect. Okay. Then determine the ratio OP is to PD. You have to determine OP. You have to determine OP is to PD. Now, what does that mean? You have to find OP upon PD. I'm sorry. OP is to PD is OP upon PD. You have to determine this. What does that mean? It means you have to determine the ratio in which point P divides segment OD. You have to determine what ratio does point P divide segment OD. Okay. What I will do is, for making you understand the question, I drew a rough diagram. Now I shall draw a better looking diagram. Okay. So let me first go for the diagram. So here you have the triangle. I have drawn this diagram for you. See, I have a triangle OAB as said in the question. In triangle OAB is the midpoint of E is the midpoint of OB. So I have taken E, point E as the midpoint of OB. See, you have OE equal to EB because E is midpoint. And D is the point on AB. This is the point D on AB.
such that AD upon DB is 2:1. So now you can understand AD upon DB is 2:1. So AD is 2, DB is 1. You need to be careful for that. You know, you cannot write 2 here and 1 here. That will go wrong. So AD is 2 parts and DB is 1 part. You need to see this and then write it carefully in the diagram. Further, if OD and AE intersect at P, I draw the segment OD, I join O with D, and I join A with E, and they are intersecting at point P. They say then determine the ratio OP is to PD. I have to find this ratio. What is OP upon PD equals to? Okay, using vector method. So here, see what I will do. I will start writing as, I will write referring to the above figure. I will write here referring to above figure. Definitely the figure is essential here. Referring to above figure, I write let O bar, okay, this is point O, so O bar. Now see, normally what happens is, when we are taking the position vectors, we take the position vector of points with respect to O, So, but here point O being a part, an integral part of the question, you know, point O is also one of the point in the question. This time, we will take the position vector with respect to some other fixed points. Okay. Normally what we do is we take the position vector with respect to O. In this question, we are going to take the position vector with respect to some other fixed point. Let that fixed point be here, you know. So I will take the position vector with respect to this. So this is O bar. This would be my A bar. And this would be P bar, D bar, and so on. Okay, I hope you understand. So in this, what I will do is I will have to write the position vector of point O as well. Normally this we don't write. Normally we don't get point O in the question. So here I write let O bar, A bar, B bar, D bar, E bar, and P bar be the position vectors of points O, A, B, D, E, and P respectively with respect to a fixed point. Even if you don't name it, it is okay. With respect to some fixed point, it is okay. Now see, next what we write. See, what I do next is I apply the section formula for point D. The solution is a very specific solution. I repeat again, what is my aim? My aim is to find OP upon PD. But in order to get that, see, how do I proceed? I will write bisection formula. D bar equals to, see, D bar is, okay, right here A bar, the position vector of point A. This is D bar. Here I will write beside point B, I'll write B bar. This is E bar. This is O bar. And this is O bar. And here I have P bar. So see, I get D bar equals to, you know, this 2 will multiply the position vector of point B. So D bar is 2B bar plus 1 time A bar, that is 1A bar upon 2 plus 1. Now 2 plus 1 is 3, so I will get therefore 3D bar equals to 2B bar plus A bar. This is equation number 1. Okay. I applied the section formula for point D. Next, what I will do is I will apply midpoint formula for point E. I will write by midpoint formula, by midpoint formula. See what I have. I have E bar equals to O bar plus B bar by 2. That is, I have here 2E bar equals to O bar plus B bar. This is equation number 2. Now these two equations which I obtain, these two equations are going to get me my solution. They will get me my solution. And how is that going to happen? See, in the first equation, I have a relation between D bar, B bar, A bar. In the second, I have the relation between E bar, O bar, B bar. Now see, D bar means point D, B bar is point B, A bar is point A. E bar is position vector of point E, this is position vector of point O, and B bar is position vector of point B. Now having all these points in the relation, what I follow is, if I want point P in picture, try understanding. If I want, somehow I have to reach to point P. See, looking at these equations, I'm not having anywhere point P. Do I have anywhere point P in these two equations? No. Do I have P bar anywhere? No. I do not have P bar. But if I want to incorporate that P bar, what I understand that P is the intersection of AD and it is intersection of AE and OD. It is intersection of AE and OD. So if somehow I end up getting relation between A, E, D, O, the chances of getting P is high. What I'm saying is, if I get relation between A, E, O, D, then I will be getting the idea about P. So knowing this, I understand that only point which is left out is point B. See, if you want to end up getting point P, P being the intersection of AE and OD, what you will have to do is you will have to eliminate point B. You will have to eliminate point B from these two equations. Okay, we will try eliminating point B from these two equations. Why am I trying to eliminate B from these two equations? Because I want the relation between A, E, O, D, which I see in these two equations. See, I do see A, E, O, D. The only thing that I do not want is point B. So I will try eliminating B bar from these two equations. So see what I write. I write multiplying 2 on both sides of equation 2. Multiplying 2 on both sides of equation 2. When we do that, we get here 4E bar equals to 2O bar plus 2B bar. I'm multiplying 2 on both sides of equation 2. So 4E bar is 2O bar plus 2B bar. I read this as equation number 2B because it is nothing but 2 only. I just multiplied 2 on both sides. And what was equation 1? Equation 1 is 3D bar is 2B bar plus A bar. So here I have 3D bar is 2B bar plus A bar. 2B bar plus A bar. This is equation number 1. See, I subtract equation 1 from 2B. So when I subtract, what will happen? You know, the signs will change here. So this is negative, negative, and negative. Okay. So I get therefore 4E bar minus 3d bar equals to, this 2b bar will cancel, positive and negative. I have 2o bar minus a bar. Okay. Now, if you remember what we had said, we had decided that I want A, E, O, D. A, E, O, D. So see, I will keep A and E on one side. So here I will shift A on this side. So 4E bar plus A bar equals to 2O bar plus 3D bar. See, O and D on one side, A and E on one side. Okay. Now you will notice something very, very, very unique here. See, very specific here. 4, the coefficient of E bar is 4 and coefficient of A bar is 1. Now what is 4 plus 1? 5. 4 plus 1 is 5. Here, coefficient of O bar is 2 and D bar is 3. What is 2 plus 3? That is also 5. So I write here dividing both sides by 5. Okay, so I get here 4E bar plus A bar upon 5 equals to 2O bar plus 3D bar upon 5. Okay, in the next step, I would write this in this way. See, I will write, therefore, 4E bar plus 1A bar upon, can I write this 5 in the denominator as 4 plus 1? Yes, 4 plus 1 is 5. And here I have 2O bar plus 3D bar upon 2 plus 3. Okay, this I write as equation number 3. This is my equation number 3. I write here equation number 3. Now see, look at the LHS of equation 3. When I see this particular expression, I understand that this is nothing but the section formula. It is nothing but section formula. Now from this, I can write, I understand something. And what do I understand? See, I will write from LHS of equation 3, from LHS of equation 3, we get position vector of a point, which divides segment AE, which divides segment AE, and see, I'm writing A then E. Okay, further, what do I write? I have a plus sign here. It means it is internal division, which divides segment AE internally in the ratio, I wrote AE, so I will write in the ratio 4:1. Okay, and look at the RHS. Okay, RHS of equation, see, again, RHS is also in the same internal section formula form. So here I will write RHS of equation 3 gives the position vector of a point which divides segment OD. I will write OD. So since I'm writing segment OD, the ratio will be, see, I'm writing OD, so the ratio will be this way, the other way, 3:2. Okay, OD in internally, definitely it is internally because we have plus sign here, internally in the ratio 3:2. Further, now see, the left hand side position vector is equal to right hand side position vector. What does that mean? It means this point and this point, they are one point only. Okay, because the position vector of that point are equal. It means that is nothing but one single point. So what I can understand is AD, see the point, try understanding. The point which is dividing AE is also dividing segment OD. It is the same point which is dividing AE and it is also dividing OD. It means AE and OD are intersecting each other. It means AE and OD are intersecting each other. And what we are given, sorry, we are given that the point of intersection of AE and OD is point P. What was the point of intersection? It is point P. So here I will get, therefore, equation 3 gives the point of intersection, gives the point of intersection of segment AE and segment OD. It gives us the point of intersection of segment AE and OD. That is 3 gives the position vector of point P. See what we got? We got the position vector of point P. Okay. So now what you can say? You can say that P divides AE in the ratio 4:1. So P divides AE. P divides AE in the ratio 4:1. So 4 here and 1 here further. What more you have? P divides OD. See, P divides OD in the ratio 3:2. 3:2. So here you have 3. P divides OD in the ratio 3:2. So here you have 3 and this is 2. Okay. So now we have the final answer. Therefore, OP upon PD. OP is to PD is equal to 3:2. We got the final answer here. I hope you have followed this. This completes all the problems from exercise. Thank you.